Hello students, today we'll solve one beautiful problem from CSIR NET 2019 June. So in that question, 3 decays are given and we have to identify the correct sequence of mean lifetime of these 3 decays. So we'll solve this question by investigating which decay is allowed by strong interaction, which decay is allowed by weak interaction, and which decay is allowed by EM interaction. So let us check that. So for that, we'll apply that conservation laws. So for first decay, pi 0 goes to gamma plus gamma. Its mean lifetime is T phi. So let us check that interaction. Let us check charge conservation. So pi 0 goes to gamma plus gamma. So for pi 0, charge is 0. On the right hand side, you have gamma. Again, that number will be 0. It means charge is conserved here. Now we'll check lepton conservation. For pi 0, this number is 0. Again, same is true for gamma also. It means lepton is conserved here. Okay. Now we'll check baryon conservation here. So none of them are baryonic particle. Again, that number will be 0, which implies baryon is also conserved here. Okay. Now we'll check isospin I. For pi 0, this number is 1, but for gamma, this number is 0, which means I is not conserved. On the left hand side, you have plus 1, but on the right hand side, you have 0. Now we'll check S. So S will be conserved because pi 0 is not strange particle, and again gamma is not strange particles. Okay. So that's why S is also conserved. I3 will also be conserved because you see for pi 0 it is 0, and for gamma this number will also be 0. So you see only I is not conserved, but all other quantum numbers are conserved here. So this means this interaction is allowed through EM interaction, and also that gamma is involved here. Okay, so whenever that gamma is involved, that means that interaction or decay is allowed through EM interaction if the all conservation rule associated with this EM interaction is satisfied. So it is satisfying that rule. It means this is allowed through EM interaction, and for EM interaction, that mean lifetime is approximately 10 to the power minus 20 second. Okay, so please note this number. Now we'll check decay 2, that is mu minus goes to E minus plus nu UR plus nu mu. So you see here neutrinos are involved in this decay. So this decay is only allowed through weak decay or weak interaction if the associated conservation laws are satisfied. Okay, so we'll check one by one. So let us check charge conservation. So on the left hand side you have -1, so it will be -1 because mu minus, for mu minus that number is -1. On the right hand side you have E minus, that number will be -1. For nu EVAR that number will be 0, and for nu mu this number will be 0. So charge is 0. On the left hand side, charge is conserved because on the left hand side you have -1, and on the right hand side you have -1. Now we'll check lepton conservation. So for mu minus, lepton number is +1. For E minus, this number is +1, and for nu E bar, this number will be -1 because this is anti-lepton particle, and for nu mu, this number will be +1. So on the left hand side, this number is 1. On the right hand side, again this number is 1. It means L is conserved. Now we'll check L mu. L mu means muonic lepton number. So for mu minus, this number is 1. For E minus, this number is 0. And for nu mu R, this number is 0. For new mu, this number is 1. So it means L mu is conserved. Now we'll check Le, electronic lepton number. On the left hand side, mu minus, so obviously this number will be 0. For E minus, on the right hand side, this number will be 1. For new mu bar, this number will be -1. And for new mu, this number will be 0. So again, Le is also conserved. Okay. Now we'll check isospin. For mu minus, this number is 0. And for E minus, this number will be 0. For new mu bar, this number will be 0. For new mu, this number again will be 0. So it means I is conserved. S will also be conserved because none of them are strange particles. So this is 0 for all particles. Okay. So you see all quantum numbers are conserved here, but this is allowed only through weak interaction because of neutrino. So because of this, that mean lifetime of this decay process noted by T mu will be approximately 10 to the power -10 second. So for this decay, you have that lifetime or mean lifetime is 10 to the power -20 second. But for this decay is that mean lifetime is 10 to the power -10 second. Okay. Now for decay C, rho 0 goes to pi plus plus pi minus. Okay. So you see, rho 0 is mesonic particle. This is vector mesonic particle. Pi plus and pi minus. These are also mesonic particle, and these are scalar mesonic particle. So whenever that all particle are mesonic in any interaction, that means that interaction is followed the strong interaction, or this interaction is allowed through strong interaction. So this means that mean lifetime of this decay process is noted by T rho, and this will be approximately 10 to the power -23 second. It means the mean lifetime of second decay T mu will be greater than the mean lifetime of first decay noted by T pi, and this lifetime is greater than T rho. So this is the correct sequence. Thank you.